Okay, arithmetic sequences. So in lesson 4.1, we learned about different types of sequences. And all an arithmetic sequence means is, think about the word arithmetic. Basic arithmetic is adding and subtracting. So when it's an arithmetic sequence, you are always adding or subtracting the same amount every time. Okay, a couple of terms to note here. What we just said, arithmetic sequence, there's a common difference. That means exactly what I just said, adding and subtracting every time. Again, in 4.1, we talked about what is known as an explicit and recursive rule. Remember, explicit, you can type in the calculator and use your table. Recursive is always based on the previous term. So what we're going to do is we're going to do these your term problems again, and then we're going to use some of the homework problems in the book in class tomorrow to be able to prepare for doing the online homework. So it says the table shows the number of plates left at a buffet after n hours. Write a recursive rule and an explicit rule for the arithmetic sequence represented by the table. So what you want to find is what is the pattern here, what is happening. So if you notice, everything here is going down. What I have to do is I have to figure out how much. So 155 to 141, I subtract 14. Now what you want to do is always check. So do 141 minus 14. Well, that gives me 127, which is the next term. So down 14, it's working every time. Now, in terms of a recursive rule, this is very easy. All that is f of n is going to be f of n minus 1, and then you put what's happening, which in this case is minus 14. Now, in terms of an explicit rule, f of n equals, now here, and the reason I'm using f of n, you need to look at your table up here. That's the reason I'm using this. But in an explicit rule, the minus 14 is our slope, which in terms of, remember, we're using the equation y equals mx plus b. Slope is our m. Now remember, b is our y-intercept, which we also call our zero term. So to get our zero term, what do? We go backwards here. So instead of subtracting 14, I'm going to add 14. And 155 plus 14 would be 169. That's my zero term. So in terms of an explicit rule, it is this right here, mx plus b, or we're using the variable n. So it's negative 14n, since negative 14 is my slope, plus my zero term, which is 169. And that's my explicit rule. Okay. This one says write a recursive and explicit rule for the arithmetic sequence given. So this is the same kind of problem. The only difference is it's not in a table form, but it's still the same thing. So all we do is we look, and what are we doing? Plus 10, and plus 10. So what is that again? That's our slope. Okay, this is our first term, so I need to go back to get my zero term, so I'm going to subtract 10. And if I subtract 10, that takes me to negative 4. That's my y-intercept. So in terms of an explicit rule, it's f of n equals m 10 n plus b, but in this case it's minus 4 since it's a negative 4. And as far as our recursive rule, it's f of n equals f of n minus 1. Then what are we doing every time? We are adding 10. Okay, another problem. This one is given to us in graphical form. Jerry collects hats. The total number of hats in Jerry's collection depends on how many years he has been collecting hats. After the first year, Jerry had 10 hats. Each year, he has added the same number of hats to his collection. The graph shows the sequence. Write an explicit rule and function notation for the arithmetic sequence. So in this case, I'm just doing an explicit rule. So again, what I'm wanting, just basically, again, is y equals mx plus b, m being my slope. So how much is it going up every time? So here I'm looking at my y values. Up 8, up 8, up 8. That's my slope. So again, it says in function notation, so f of, I'm going to say t because it's in time. F of t is 8x plus, now I need my zero term. Well, this is the first term. So if I go backwards to the zero term, then I'm going to subtract 8. 10 minus 8 would be 2. So that would be right about here. And that would be at the point 0, 2. So there's my zero term. So that would be plus 2. Oh, mistake here, sorry. That doesn't need to be x because I had t here. So I need to put t. Okay. So now we're kind of into the homework section. And what we'll do in class is we'll do some of these problems. And then hopefully you'll be prepared to do the online homework.